Hello, everyone, and welcome to the broadcast. I see Tass and Halfblind have joined us already. Welcome, everyone. Hopefully, we're all doing well. It's been a bit since we've been rolling here. Sorry about that. We do have all four kitties present already. Ember has claimed her natural spot. Sammy is jammed up in the cat tree with Sky. And Mason and Sherbet are over there in the bedroom. The light's a little dim in there, but they are both present. But hello everyone, welcome. Let's see. Guess what you got? What do you got? What did you get? I got streaming again. My eyes are still being all wonky. That is a VR headset, right? I've thought about trying one of those again. Back in the day, I tried one of the Steam ones, and I could never get it set up properly, so it got resold. Perhaps someday. Okay. So the title of this references the idea that despite the fact that I said 15,000 was good enough, I feel like it could be better. Well, thanks for swinging through Halfpint. Yeah, I figure we can do a little better theoretically. If this doesn't work, 15,000 is good enough. As a cap before things choke out. If we can get this to work as is implied by some experimentation that Parakeet did, even by doing brute force computation, that is an n-squared check of every entity against every other entity, every physics frame, we would be able to do way more than that. So many that we should never hit the limit, which would be great. So I've got the bare bones of it started. We do have an alternate collision manager. This is where our efforts to abstract the objects and make the choice of which ones to use part of resource files of great value. So we use this instead, and we've got this file here, which is using tutorial placeholder script at the moment. This is a OpenGL shader language shader. It is a compute shader. That is up here. Its type is a compute shader. It's using GLSL 450, which isn't going to change. Because apparently this is what Godot uses currently. This is how the computation happens. So shaders run in work groups. Those are parallel threads running on the GPU. And then within that work group, you can specify essentially a nested for loop, X, Y, Z, where for each X it will run this many Ys, for each Y it will run this many Zs, kind of thing. And what we'll do is we will subdivide we're going to look at subdividing the shaders down. But to start with, we may just do one of them and feed it in and just say, okay, X is the we iterate over X for the each entity, and Y is the entity list again, where it is comparing the pairs X and Y, X and Y. We will ignore the check if X and Y are equal, and we will ignore the check if X and Y are of types that don't collide. So the player and a bullet don't collide, so we just skip that check. Part of the trickiness of this is setting up data buffers. This is how we get information from the C# code into effectively the GPU, into the shader code. We need to set up bitwise data buffers, like precise byte structures. We are not going to mess with this stuff. I believe we leave set and that value alone. The binding, I believe, is just an iterator. So, binding 0, 1, 2, which bind we're dealing with. And then the code to execute. And we can see here global invocation ID. That is these values up here. So what the sample code does is it takes this data buffer, loads it into this my data buffer. It is a array of floats, and the X that is coming in, it's iterating over everything in the data buffer and multiplying it by 2. This data buffer, this address is still the same. So the floats here that are being, like the array that is created outside of the shader, is being directly manipulated here. We're not going to do it precisely that way. And we're going to need several of these data bindings here to accomplish this. We need the X and Y position of it. We need to know if that particular one is active or not. Since entities will have IDs from 0 to however many entities are allowed to exist minus 1. That's how many slots will exist within the collision manager. We'll use the same IDs. And that means that whenever an entity is removed from the entity manager and that ID becomes available again in the entity manager, that entry in the collision manager, the shader collision manager, needs to be set to disabled so it won't collide anymore. So we have the enabled value. We have its X and Y positions. So we're up to 3 floats at the moment. We need its type, which for simplicity is probably still going to be a float. Shaders want values either if you're dealing with floats or ints, it doesn't really matter. They're the same size, so it could probably be an int again. But you want them in pairs or groups of 4. Because a lot of the compute shaders are meant to operate on 2D space, or like they're operating on vector 2s or vector 4s. It's just how they're set up to do. And a vector 2 is, as far as memory is concerned, is just 2 consecutive floats. Same with a vector 4, 4 consecutive floats. And in C#, int and float are the same size as far as memory. So it doesn't really matter which one we use. But again, maybe floats for consistency across it, just to be sure that we don't get any oddities. We need its type to determine if it's going to collide. We need its radius as far as the collision shape is concerned. So the position of the circle, the radius of the circle. Is it active? What is its type? Then we will have corresponding lists. We get the big list now, and that is a two-dimensional array. So for each entity, we determine how many collisions there are. So there's another value, number of collisions. And then we have an array for it, which is those collisions. So if we have 20,000 entities, that is a 20,000 by 20,000 array, since a given object could potentially collide with every single other object. So its value would be, 20,000, and then every entry in the array would be the consecutive list. I mean, technically 20,000 minus 1. It should never collide with itself. And then once we've got that value, that two-dimensional array, we're going to iterate over it on the outside, and we're going to create collision events for every entry in that. We'll say, okay, for the first entity, it has X collisions, and we iterate over X on that array, on its array, and create collision pairs for each one. Since most things won't collide, we're going to get a slightly heftier N as far as iteration on the C# side. Probably something like, 2N-ish. Because we'll need to make sure that we're updating it, but that will be happening on the fly. The list of them will only be updated as needed. So an object's position will be updated, and its active state will be updated. Potentially each frame, but not always. An object need not move every single frame. So that'll be event-based. Its type will only change. Its type and radius will only change upon being created. So those will be set when a new object is created. We set those, and then we make it active. And until that object leaves existence, that data will not change. So yeah, that's what we're shooting for. So this will get updated heavily shortly. Have our shader collision manager here. I'm looking at this semaphore. I might just ignore this for now. Since we're going to have some static values that we're going to create here that we don't want to reload them. Like, once I create the actual shader, I don't ever want to remake it. So we've got our tutorial here. We get our shader file. Some of this song and dance here is to get that path without having to fully hard code it. We're saying that the collision check shader will be in the same directory as the code of the shader collision manager. So up here we have shader collision manager. It's right by my ear. And in the same directory is collision check GLSL. As long as the pair are next to each other, we don't have to worry about the path, because we're going to load a resource. We're getting the script. We have to do that in the local constructor, because this relies on an object existing. A Godot object needs to exist. So we get the script. We treat it as a resource object, because this is a variant it's null or a thing. And we get the path, the resource path to it, which should be, for this one, collision, shader-based, that pathway. And then we're going to append this file. So this is the constant string that has to live somewhere. I wish we didn't have to do this. I wish it could be in a resource file. As like not a string, that I could put a reference to the file in the resource. Without it being a string, because the string can change. But this way, as long as the two are adjacent to each other, this should work. This should work. So what we're going to do... in fact, we're always going to call load shader. Load shader will do nothing if the thing that we're ending up with is already set. It's not going to be this. We'll get to that if in a moment. Because we're getting the shader file here. Then we're going to get bytecode. Get. Tell me about this function. Wow. I don't understand pretty much any of that. SPR-V intermediate representation for the specified shader version. Which I'm assuming... pass in there. Okay, it's probably going to extract that from the file. This bit right here. The version string here. Need a RD shader spear V. Entirely local. We're not dealing with those. So then we need the actual shader is need a rendering device as well. You'll need to keep that one. I would like these to be read-only. They can't be read-only. Because, again, they rely on instance-based methods, non-static methods. It was fine with this earlier. Okay, it's because we have this dangling element here. Guessing this is going to be a rendering device. create local. So we're setting up the rendering device. We're going to keep this around because we don't want to keep remaking it every time you start a new game. So this collision manager will be created and removed as part of a game startup. But that create and remove is primarily going to be to flesh out the contents of it when it's initialized. So we'll go through and scrub everything just to be sure. Scrub everything that need be scrubbed, which is ultimately going to be going through and setting all of the entities to inactive and all of their collision counts to 0. Okay, we have that, and then we're going to make the shader. So shader create from sphere V. Creates a RID. Okay, so this will get us our shader. This is where a mutex would be useful. So if we've not created the rendering device, we won't have created everything else. If we could if we wanted this to be truly thread safe, then we would wrap this in like a mutex here for the static. That way, during the load up, when we call load shader, it would block on that mutex, that flash semaphore, and prevent something else from getting into this null check. Okay, so we've got our shader. And we've got it loading from that relative path. This should only ever happen once, effectively. Then similarly, we are going to need to prepare our buffers, which are going to be a series of, like, effectively old school arrays. And these too will be static. We don't want to be recreating these arrays over and over. It will fragment the memory pretty speedy. If we just... We're looking at a couple of megs of memory being created. It's not... Well, not just a couple. But we're looking at a bunch of arrays being... created at once. It's a bit of an edge case that it would fragment too much, but we don't need to be constantly trying to find contiguous memory this way, where every time you load a level or something like that, we recreate these swaths of arrays. All right, let's look at how we do here. So this is one thing that we can do, is we can create the floats. And then we can, in this case, what they're doing is it's not the way you need to do it. There's a sample below that we're going to reference here. They are creating a float array, and then they're creating a byte array that is the size of the float array, and they are copying the content of the float array into the byte array. We're not doing that for the aforementioned reason. We don't want to be constantly recreating these things. So this is create storage buffer. We're going in and saying like, okay, we create an unsigned int, which is the length of the array and the array. And since it's a byte array, the length of it is the number of bytes. And then we are going to create uniforms. These are fixed values. Not really fixed values, they are variables that are uniform across all instances of the shader. Every time we execute it, those values will be shared. So if I change it for 1 and there are 10 instances running, all 10 instances get that value. There are instance uniforms that you can use in other cases. I know you can use them for vertex shaders, where you say, for this particular instance of this shader code, we will use this variable. Which could be handy in some places, but that's not how we do. Creating uniforms for that shader. So we're setting up these uniform values in the shader. Then what we're going to end up doing is we're going to have these compute pipelines set up where we say creating it, we're saying, okay, here is the uniform set that we're making. Then this is the number of work groups that we're setting up for it within that rendering device. These are the number of essentially parallel executions that we're doing. This might be a way for us to make it even more efficient, where we could say there's 5 of them, and we subdivide the entirety of the Hey there, Blood Mage. It's moving along. We've been offline for a little bit here, but we're making steady progress. We've gotten a bit hung up on performance again, but we have gotten our collision count, our entity count upwards of, I think, 10,000 running smoothly, with a cap of about 15 before it starts to drop, but stays above frames, in frames per second. Hitting 20, we get into seconds per frame. we're looking currently at using a compute shader for our collision checks because there are some indications. Parakeet in the community has done some testing, and it looks like doing that would essentially remove the collision check as a performance concern, assuming we don't let things move too fast. We'll have to see. So then we submit it, we sync it. Now, the sync you don't want to do in the same frame like this because it makes this line block for it. But if this operates correctly, waiting for the GPU to finish this calculation is still nothing compared to a physics frame that has to do it itself. We'll see. Then we get that. We are going to pull data from it. Now, we'll have to see how this goes here from the buffers. Where are we creating that buffer? Storage buffer with binding 0. Okay, this is where it becomes relevant because we have this storage buffer entity. All right, Blood Mage, have a good night. Sleep well. Okay, when we're creating the buffer, when we're creating this uniform, this is binding 0. Reference that. We're working through the tutorial together. We're all learning together. The shader language is its own thingy. GLSL. So this binding 0. This is where we're finding, like, that buffer is what we're interacting with here. Set in standard here, this is formatting information. I don't know that they describe set. And the specification for GL shader language is, we're going to call it low level. So we're creating our pipeline here. This is just a pattern for execution. Yeah. So this is stuff to do. Here is then we're making the list of instructions, the compute list. We put them together. We add our uniform set, our data, essentially. And then we are going to say that list of instructions gets this pattern of worker groups. And this is a nested for. So it's multiplicative. If you were to increase Y, it's for each X, this many Ys, this many Zs. So with this, there are 5 work groups. So if we look, there's 10 values here. Let's see. in their shader code, they're saying local size 2. Hey there, Gamma. So if there are 5 work groups and 2 local instances, each work group will handle 2 of them. So each worker is going to have, each one of these iterations is going to have that multiplier in there. We're going to need to figure out precisely how to do this. And I think the global invocation X is worker X and local size X. If that is the case, that helps us. But we'll see. So we want as much of this to be handled as possible. Okay. This is dangerous territory, what we're heading into. So this is calling out same thing I mentioned. Doing block copy is wasteful for us. We don't want to constantly essentially create an array with a bunch of values in it and then take that chunk of memory and put it into another array. We don't want to double the amount of space we're dealing with, and we don't want the overhead of the duplication. So instead, what we can do here is we have our input value. We can create it as just like essentially a span, an area of memory. So we say this is a float array. It contains data. And then we're going to say, okay, input bytes is an array of bytes using this chunk of memory, this same chunk of memory. So if I mess with input bytes is the same thing. It's the same thing. Now, so you can do it the other way around as well, where I could create the byte array and then essentially say that input is a way of addressing the bytes as a float array. So if we make the bytes, X size of floats, then if we treat it as a float array, there are X floats. Whereas this way is saying I have X floats, input bytes is the memory encompassed by that array. And you can do it this way as well. We could essentially have all of our property elements as a struct. But I don't know that we're going to get away with that. I feel like it's not really going to get us anything, because we would need to recreate this fully in the shader. Where we would have to define the shader side, that struct. So there would have to be a struct defined in here where we say each one. I feel like just having more buffers is going to be the way to go here. But we'll have to see. All right, so keep hitting the wrong thingy. So then we need... We're going to have... So we have an active buffer. We could probably make these vector 2s. One of the difficulties is the shader language is not, native to Visual Studio, and I can't find any good extensions for it. There are a couple, but I prefer that they come from more quantifiable or more verifiable sources, as opposed to arbitrary group, since Visual Studio extensions have a lot of power. So in theory, we could set up structures and whatnot, but let's see if our... I wonder why YouTube chat is so flaky on my end. I think for now we're just going to use a series of floats as so our layout values here. We're just going to have a bunch of them. X, our position Y, our radius. And then so this is effectively a Boolean list. This is a pair of floats. We can treat all of these as floats. To my understanding, though, buffers will always be... When you're setting up a buffer, it carves it into units that are... The smallest unit is the largest thing in the structure. So if I pass into a buffer a structure that is like a byte and a float, what I'm going to get is two allocations of memory the size of a float. Then we take that size and it will be scaled into units of either 2 floats or 4 floats, whichever is necessary to encompass it most effectively. So if it's bigger than 2 floats, it'll be 4 float units. So ideally, any buffer is made of things that can be broken down into 2 floats or 4 floats, which is part of why we're just going to make a bunch of buffers, because it lets us dodge this problem. We could make active a Boolean value. We may do that. Position X and Y, we could make these vector 2s. I don't know what the syntax for that is in the shader language. So we're just going to make those 2 buffers for now. Collision count could be an int. We can treat it as an integer. It's the same as using a float. This is the complicated one, but we should still be able to treat it as a 2-dimensional array. We'll see how that do. How are we going to deal with the marshalling of it? All right, let's get those rolling. I'm using protected because I don't know, maybe I'll make a child class of this, but nothing else should be messing with these. It would be bad if anything else messed with these. This will be our syntax. X in position Y. All this is pretty crude at the moment, at least as far as our plan, but we want a proof of concept here. If it works fine with what we're doing, then it will work fine beyond that. That is, if it works fine with this kind of crude bludgeon method of defining everything, then it should still work fine if we tighten it down. Do news on this. be able to define this as just part of the listing up there. Okay. Need to allocate that space too. So I think we can just do all of this down here for simplicity. I think for simplicity, so there it's all in one spot where we're setting these up. All right. So we're initializing all of the buffers. Including the 2D array. And we need we're going to create parallel ones that are byte arrays. This is the one that I'm concerned about. Will I need to do something differently here? Hopefully not. Otherwise, we'll need to go through and have the marshalling done on each one of them. We'll see. As bites. Hey there, Levi. Good to see you again. More cats indeed, Levi. More cats indeed. And thank you for 12 months. Your icon kitty count grows. Bytes, then our value as a span. All right, these need to be a span of bytes. Oh. Why you gotta bring up time, Levi? Okay, this is just a span of bytes. Isn't it, Tass? Isn't it? Oh. Don't want to have to remake this each time. Just a moment here. It says, Alt O for examples and documentation. There aren't any. Reference struct. So what I'm trying to do here is also have these byte fields be the same, but actually, do they even need to be? Are we ever going to need to do this multiple times? Because if I'm creating a reference to it, then I'm going to pass it into the pipeline as a memory address. I don't think I need to keep these. Okay, let's go with that. Okay. This is the one that kind of concerns me. The collision buffer. We'll get there in a minute. So what we're doing here is we're setting up some member variables that are a byte array that corresponds to our actual value array, because the shader wants it to be in terms of bytes when it's passed in. My concern here is, do we need to do this multiple times? Because eventually I'm going to want to do something like this where it's a struct, but again, because these have not been initialized yet. These live in different spaces. But their values should be the same. Ultimately, we'll see if this actually works. This is the one that concerns me, the collisions. Because we won't be passing in byte values for those. Let's do that. Let's do this here, just in case. Okay, then for each one of these, we need to set up our uniform here. So our rendering device, we're going to create a storage buffer. Storage buffer create. We need our size in bytes and our data. This is why we want to keep all of this stuff around. length and our bytes. Signed integer. Okay, we have a this is a byte array. This is creating a span. Okay, to array. So we're going to create a storage buffer from that. Then we're going to create a uniform we should not need these buffer references and uniform references after we're done with them here. So we're going to set up its binding and its type. We do this for each of them, with the binding increasing by 1 each time. do something with our uniform here. We're going to create an array of uniforms. And we're going to populate it with each of the uniforms as we set it up. Array RD uniform, the shader set. Well, we're going to assume that's 0 for now. During Hey there, Harry. There's a disjoint to the phrasing there. But we're doing well. We're doing well. And yes, James. Oh, we're getting there. We're getting there. RD uniform, shader, uniform set. Okay. Don't worry, Harry. We've been offline for almost a few weeks now. But doing better. Doing better. We're online again. We're streaming again. So, you know, we're making ground again. We are experimenting with using shaders to do brute force collision calculation to try to remove collision calculation as a performance hitch. Uniform set is created using the array. No worries, Harry. We're working in compute shaders right now, which I have never touched before. We are in foreign territory right now. Okay, so we have a new array. Each time we create a new uniform, we're going to add it to that set. just so. Just so. So we're creating a series of uniforms with an increasing binding. We are going to just put little brackets between this so we can see more clearly the division. This is still the one that concerns me. We'll see. We'll see how it do. Because we're ultimately just dealing with a space in memory. We're referring to a space in memory. I don't know if a two-dimensional array is going to play nice in this regard. So I would love to be able to define it all at once. Because that would give us a truly contiguous series of memory there. We would have, max entity blocks of max entity. We're in an interesting space here. I mean, that's what we're trying to do here, Harry. So, I don't know if you're familiar, but, where a lot of the game runs on the CPU. The graphics and whatnot normally run on your graphics card, your GPU. With a compute shader, what we're doing is we're taking a chunk of math and we're telling the GPU to do it. Telling the graphics card to do it, because graphics cards are really good at math. Exceptionally good. But what we're working with here is figuring out how to bundle up all of the information that we want it to... all the stuff that we want it to do math on. We're trying to bundle it up properly so we can hand it to the GPU. Let's the radius buffer bytes. So we're doing the math for how we detect that things bump into other things. And what we're hoping to be able to do is, instead of having the Godot physics process do it for us on the CPU, we're going to do it crudely on the GPU. We're going to compare every object to every other object, which is just computationally messy. It's an n-squared operation, which means for every, if there are 10 entities, we have to do 100 checks. But if we job it off to the GPU, ideally it can do it super fast. Okay, so then we have the uniform array. So now we need to create our uniform set. Okay, we have our uniform set now. Pipeline in compute list should be unchanged. Compute pipeline create. Okay. Just posture. For shader. We don't even need the shader when we're done with this. By the end of all of this song and dance, well, P4, hey there, and welcome. Our IDRs. Thank you all the same. Indonesian rupiah. Okay. Well, thank you. I appreciate it. We're doing some coding on our game project here. Well, thank you for swinging through, Harry. Hope you have a good rest of your day. Okay, we'll keep the shader as it is for now, but from the looks of it, that's not going to need to be kept around either. It will be kept inside the rendering device. Okay, using the shader, it's going to get a okay, then in list compute list begin. just returns a long. Then, okay, so we bind the pipeline. We add the uniform set. We bind the pipeline. We bind the uniform set. We create the dispatch, which is the groups. Hopefully we won't have to do this repeatedly. We might have to do this whole sequence repeatedly. If we do, that means more of this stuff needs to be saved off. If we don't, then every time a physics loop comes up, we just say submit sync. Okay, we bind the pipeline. Then we are going to bind the uniform set. Zero there. Am I sure why? No, that's unfortunate. This dispatch, which is the list, then X groups, Y groups. List. We're just going to see if this functions for now. Okay. So we have set this whole thing up. Compute list end. Okay, so the rendering device is ready to fire now. All of these values, the byte array that we've got, the hope here is that it's still just keeping the memory address, because a byte any array, the variable is not like the array variable is not like a number, it's an address. It's where the start of the array is. And the fact that it's a float array just says when I say array 0, it's the base address. When I say 1, it's one float size in bytes to the right, essentially. So we should just be sending addresses to it. So calling it numerous times should still function for us here. Okay, so we have a series of bindings. This one still bugs me. But okay, then we submit and sync. Okay, this one entirely. Let's see, a collision manager is a node 2D. Yeah. I'm going to want to figure out a way to pause. We're going to have to figure out a way to pause. Okay, so I'm going to go into a collision manager here. Hey there, Y. We are working on our game. Is it still functional right now? Been a lot of coding at the moment, but I wonder if it still runs at the moment. Oh, it still runs. Okay. Making a Vampire Survivor style game. One gated. With the gimmick being that it will use a Noida style weapon creation system. So we can drag and drop elements of this in here. And we'll wait for a moment, and then we'll split into 3. Let's take all these off here for a moment so you can see it happen. So initially it's just firing these little balls of yarn off in random directions. Oh. Oops. We've got to wait for that to disperse. Okay, so the little blobs track the cursor at the moment. But you can see the yarn balls are firing off in random directions, moving relatively slowly. If I put one of these 3s on it, now they go off in groups of 3 each time. If I put a second 3, they split into 3 twice, so they're splitting into groups of 9. There's overlap. It just looks like groups of 5, but it doubles up a little bit in a few places there. Essentially, the center 3 are actually doubled. Ish. Then we can take this and make it so that they spiral out. So now they're still moving in a random direction, but it's an expanding spiral. The spiral out? Yeah. It's an expanding spiral that is dragged in the direction that it was moving randomly. Then we can wait several seconds. I think this is actually spiral in. Yeah, that was spiral in. This is spiral out. So we say spiral in, and spiral in is going to make it do little loop-de-loops as it moves outward. So we get tight little circles. But then we're going to wait a few seconds, and we're going to make it spiral out too. Or just in general, we wait a few seconds, and we start spiraling. Then we can wait a few seconds, split into 3, wait a few seconds, split into 3, and then wait a few seconds, spiral. So just before they go away, they start to spiral. Because they only live about 10 seconds, and each of these waits is 3. So they split, then 3 seconds after, they spiral. And the blobs will spiral inward. So this is what we're working towards here. Okay. So the trick with the collision managers is I don't actually want them firing every time. And the shape collision manager will be firing constantly unless we pause physics handling. Okay. So for the time being, score physics process. All right, so we're just going to use the Godot physics process here. And this will be rendering device dot submit. Okay. So now we have a functioning collision manager, quote unquote. It is a collision manager object that we can use to create another scene that we can load into our resource and use that instead and verify if it explodes or not. Compile. So we have our shape-based, we have our shader-based. We are going to create a new scene. Which extends a node 2D, which is a shader collision manager. Manager. Take that, we're going to attach a script, which is shader collision manager, which is that one there. Okay, so then we need our resource. Default startup resource, and we need to replace our shape collision manager with just a with a shader collision manager. Okay. We're just going to do one here. And binding 0 in our shader collision manager here. We are going to close everything else. Binding 0 is an active buffer of booleans. So in our collision check, we are going to say that this is a boolean. This is the active buffer. Called active buffer. Oh, hey there, Alkaline. Welcome. All right, we're just trying some stuff here. So 0 and 2 should be set to true in this. I don't want to import that. I also want to see what it's complaining about ultimately. Anyway. Okay, set 0. The set is the uniform set, I bet. Data, okay. And now we have to extract the data here. We should just be able to marshal the output into floats in the same way. Let's try that. Buffer get data. We're going to need the buffers too. But the only buffers that should have data are collision count buffer and collisions buffer. These aren't actually buffers. This is the data for it. should just be getting a reference out of this. Looks like we've hit our second hour mark already. Gonna take a quick break and be right back. We'll go from that. Oh, static. Be right back. And we're back. They're all congregating. Weird. Let's see. So it read it from the array and it so we need the buffer that we're storing to here. Okay, so I don't want to mess with. I don't want to keep active buffer because we're long term we're not using that. But collisions, it's collision count. It is static ID. Wait a minute. I'm missing something. Where are we adding the buffer? Add ID buffer. Oops. That's for each of these. So now we want to get the data. Buffer get data. going to return a byte array. Be able to marshal it back. So it would be it's equal to marshal.cast byte as float. Okay. Buffer is that is collision count. Buffer 4. Right. It's something in here that we could use. Join. That way. All right. Does it explode? It do. Okay, that's why it's giving us the full path. Like down to the CS. Okay, there is a... Well, it was giving us the full path to this CS file, which is not what I want. I need to pull it. I need it to be the folder path. Because this resource path is this thing's path. So we need... There was a method. There. Try that again. Hello, Displant. We are working on our game. We're trying to make kind of Vampire Survivors meets Noida. So we can do things like dynamically change how the objects behave. We're working on a new type of collision handling logic. Okay, so the data doesn't seem to be changing. I don't know when I set that follower goal, but Twitch has declared that 360 followers was a goal met. So I guess thank you, thank you, Displant. Now, this could imply that our shader is not working properly. So set 0 binding 4. Calling it collision count buffer. It has an internal value, which is data. Binding 4 should be our collision count buffer. Yep. Add that uniform to the array. Well, the thing is, we're not even getting this debug print, which is odd. We should be getting a print here. Maybe... Okay, let's... Not yet, Lunar, but that actually would be kind of funny. Okay. Debug output is outputting debugger. Uniforms for set 0 were never supplied in the pipeline. Strange, but that's an error. Have to do this whole song and dance each time. Feels like that shouldn't be, but you know, it's possible. Shader set 0, yeah. So this uniform set should be 0. We give it the array, which we've been populating with uniforms. Uniform type binding 4 set 0. Expected storage buffer supplied uniform buffer. Is that wrong? Storage buffer. Storage buffer create. Right there, 2 and 5. Okay. Okay. Indeed, progress. All right, now we need to make it do something. Oh, okay. Now we need to try the other buffer. We need buffer 5 now. Okay, so binding 5 is trickier. So Godot doesn't like the compute shader when it tries to touch it in there, which is why in the Godot documentation it says you edit it elsewhere. Sure. Should be integers. Because those are references to entity IDs, which are integers. Yeah, I understand. Keep all tapping. Okay, so collision count buffer 3 is the relevant one. me do. Plus blue 2, 3, and 4. Maybe it was less than. We are going to iterate over the collision data. Just height, int. This isn't an array of ints. See, we can't use int array here because it's not just a span of integers at that point. All right. just a second here. Doing a quick code lookup here. Hey there, Laura. Huh. What are you doing today, Laura? This is going to get us a byte array. And this is going to get us a span. what is it turning it into? What are we turning it into? Don't know if that syntax is going to work. Okay, so we've got a two-dimensional array that we want to treat as a... Make it an... Can we make it an intermediate there? So we're creating the bytes of that array. We're initializing it as one big lump. By doing this, it should be one giant lump. In this case, oh man, that's a big number. Like 40 million integers. So, great big chunk of memory that this is munching. So we're converting it into a span of bytes. So it needs one big continuous slice. That shouldn't be a problem because we're not recreating it. So what I want is I want this as an array. Or even just this span of bytes. Okay. So what we're going to try to do is we have our collisions data here and our buffer. Oh, but it's a span. Okay. Bytes is equal to that. Okay, so we're storing the bytes off, which means we should be able to that. Now we've marshaled these together. This should be the same address. And because it's the same address, we should be able to treat it identically. In theory, this will work. Okay, it's not exploding. Build. Run. Okay, so this is flaws in the byte code. Let us do that. Been a while since I've dealt with C-style code. I don't know if we can do that. I think you do. I think you do. Because this is C-style. Oh. Sure we get the proper test here. Still got errors. Yep, you can see it ripples through. We don't even know if it's marshalling properly here. Okay, collisions data is properly gigantic. Oh, good point. Good point. I recall this is a test. I don't like having to put that there, but you know, it is what it is. Okay, still doesn't like it. if I were defining the array, that would definitely be true, because it wants to know all of it. The only dimension of the array that can be uncertain is the last one, if I recall correctly. Right, let's check something here. Okay. Okay, so the shader language doesn't allow multi-dimensional arrays, but we can get around this through memory shenanigans. Since we have defined it as a two-dimensional array, in theory, it is contiguous memory, which means that the memory is offset. So the equivalent of, so this is the first position. If I wanted the second position, it would be that. So we are going to try this. We are going to treat it so to get the first value in the second array, to get the first column in the second row, that would be 20,000 as an index. To get the second column, it would be 20,001. So there should be 5 collisions in row 3. The 6th one, just to make sure that it doesn't show up. Okay. In theory, this will work. Okay. No errors. Our output isn't what we want it to be, though, which we can find out over here. Not there. It's going to be in here. Oh. Wait a minute. 5,000 in there. X entities in entity manager is... How is that 5 then? As it's a constant on entity manager. It's 20,000 in it. Why is collision data 5,000 ints in size? That's weird. Okay, now it's 20,000. Still 20,000. Okay. Further problems. Well, no. That's weird. Yeah. It's like it's smushing it down. Because this should be the equivalent. Just putting this byte array directly into the bytes should be the same thing. I don't know why we have to do buffer get data here, but it might... Okay, calling this might be updating it with the changes, but we'll see. We'll see. Okay, collision count data is 20,000 in size. Still shrunk down. Okay, we're gonna set this aside for a moment because there's something wrong I'm doing with this part. We're gonna do 2 through 5, or we're... make a whole new. Or remove that to begin with. Print. high. Let's not explode. I think with zeros. It's actually weird that that's 20,000 bytes. This is ints. Go into our immediate window. Say collisions data. That should have a value in there. The other way around, though. Still getting nothing out of it. It implies that we're not actually changing the right thing. Yeah, that shouldn't be 20,000 bytes. And that shouldn't be 5,000 ints. So the way I'm doing this, there's some fundamental flaws here. Something about the way I'm marshalling this is not coming out correctly. Count data is 20,000 ints. It's an RID though. That doesn't help us. That's not right. Oh. Because this is a Boolean. Because that data was wrong. Now, we could still end up with some problems because of that. But we'll see. Yeah, we messed that up with a lot of things. We didn't change this marshaled value. Data. Visions data. Okay, so what we're looking for is a way to get a span that corresponds to this in order to marshal it into bytes. Because we need a span. Get us a reference to the byte. Ember has taken up residence, so there we go. Oh. Is this what I want? Because if we make it an array of arrays, then we aren't confident that it's contiguous memory. Well, I think we've hit a bit of a roadblock, folks, so good stopping point. Got to think on this a little bit further. What we're facing here is just low-level memory management, just. We need to make sure that we structure the data properly such that we can properly interact with it when we get it to the words and things. When we get it to the shader side. And I think on the shader side, we need to interact with it appropriately there. But the trick becomes, how do we handle that? How do we handle that? We'll have to see. We'll have to see. There we go. All right, folks. I hope you had a good time tonight. I hope you enjoy what you saw. If you did and would like to see more, remember to like, follow, subscribe, all that good stuff. And if you want to see some of my other channels, there is a link to a link tree in the description of my videos and in my Twitch profile. Let's see, next stream is still not certain. Hopefully we will get back into the pattern and try to get this rolling daily. But I will post the stream on YouTube and try to notify on things like Twitter and Blue Sky and on the Discord when they become available. All right, with all that said, folks, I hope you have a good rest of your day, and I'll see you next time.